In this video, we'll take a look and review linear functions or lines and what they look like and what we know about them. Well, a linear function, you may have learned in previous courses that it's simply a function that looks like a line or has an equation of y equals mx plus b, but there is a little bit more to it as we're going to see it. The main thing we know, it's a function with constant rate of change, or how much it changes. Another word we use for it is slope, is the same everywhere. If you take a look here, we have a straight line, but notice from any 2 points, if sort of the run is the same, okay, so horizontal, so let's say over 1 second increments or over 1x or over 2x, whatever the run is, the rise in this example is the same. So notice how it's the same slope. So again, not just the slope, but how much the line changes, whether it's rising or falling, is the same everywhere. So later on, we're going to look at data or different values, and we can also tell by table of values whether it's linear or not. Here is an equation of the slope that we typically know from previous courses. That's the change in y on the top, how much the y changes. We usually can subtract one y from another, and the denominator is how much the x changes, which is x2 minus x1. And we also know different equations of the line that can help us. For example, point slope, all we need is any point, we call it x1, y1, and we need slope, and we can actually put it in this form. But we don't want to stop here because, as you may well know, how many points are on the line. There are actually infinitely many points, so you don't want to have infinitely many equations for the same line. That would be too confusing, right? Don't want to stop here. You want to go to the next equation. Let's see, slope-intercept form. This one is going to be unique equation y equals mx plus b, because how many y-intercepts can the line have? Well, only one, because it can only cross y-axis once, so this b would be unique. So if we don't know the b, we can actually go from point slope form, we can distribute the slope, and then we can add this y right here. And by solving for y, essentially we're getting it to be in this form. So point slope form is usually equation you want to start with, and slope intercept y equals mx plus b is what you want to end with. And these are information that we know about it. M is a slope, 0b is y-intercept, if we write it as a point. So let's take a look at some problems. How many ways can we graph lines? Well, here's the most basic way. We can make table or plug in different x, solve for y, and so on and so forth. We can also find intercepts. There is x-intercept and a y-intercept. That's usually useful even for other functions that are not lines. And use a slope and a point, as we're going to see in the next example. So graph the line. Here I have representative. Here is a point, 0, 5, and slope is -2. Typically, if we want to graph, we want to write slope as a fraction, rise over run. So it's -2 over 1. And then we started with the first point is 0, 5, right here on the y-axis. It actually happens to be the y-intercept. And then, in no particular order, but what I typically do is go to the right first. And I usually go to the right no matter what, to keep it less confusing. So we go 1 unit, which is the run, to the right. And then, since it's a negative slope, we go 2 units down. So I think of it as a falling line. And here is our new point, which is namely 1, 3. And then we can just simply join those 2 points and we get a line. Now let's take a look at another example. Here we have a point 2, 1, and slope is 3 over 2. So here it's already a fraction. We start with a point 2, 1. Here's our first point. And again, we can go to the right 2 points, which lands us at x equals 3. And then we can go up 3 points, which lands us at the point 3, 5. And so here we have a rising line because the slope is positive. Okay, let's go to, now let's take a look at some equation of the line. the questions. Here's one example which we actually worked on last time. What if the line contains 2 points? How do we write equation of the line? And we want it to be in slope-intercept form. If you recall, it's y equals mx plus b. The most well-known one. So it's contains 2 points. The first thing we can do is find the slope, which we do right here. And then we can use either one of the 2 points, whichever one looks a little easier, or whichever one you want to pick. I decided to pick 1 comma 3. And let's see what it looks like. So we do y minus the y of the point, minus 3, equals to 1/2, the slope, times, in parentheses, x minus 1. So then what we want to do next is solve for y. Sometimes we have to work with fractions. There's really no choice. So what I did was distribute the 1/2. So we get y minus 3 equals to 1/2 minus 1/2. Simply multiply 1/2 by 1. And then what we did next is add 3 to both sides. Again, it's negative 1/2 plus 3, so somewhere on the side I decided to work that out. Negative 1/2 plus 3 over 1, how I write it. Notice, take a close look at denominators. The 2 and the 1. With 1 it's usually easy. It's typically 1 goes in pretty much everything. So you want to pick a number that both of them go into. Well, 2, because 2 goes into 2 and 1 goes into 2. So negative 1 over 2, we keep it the same. I rewrote 3 over 1 as 6 over 2. Notice it's still 3 if you divide, but it's 6 over 2. And so now we add and we get 5 over 2. Notice we keep denominator the same. We add the numerators. So then we go to the next step, which is y equals 1/2 x plus 5 over 2, which we had gotten on the side right here. And that's the answer. The next question, what if we have x-intercept and y-intercept? Notice how they're not written as points. We're just given values, which can happen sometimes. The first thing we want to do is write them as points. So the x-intercept would be negative 4, 0, because that's where it passes x-axis, and y-intercept is 0, 4. Remember, it's the opposite one, that's 0. So now we can find the slope typically. So again, we subtract the y's. I did the 4 minus the 0, 4 minus 0, and then 0 minus a negative 4. Remember, minus a negative actually becomes positive. So we do get 4 over 4, which is positive 1 in this case. Now we can, here's a nice, since we already have y-intercept, notice it's 0, 4, we don't really need to solve for b. We already have b. So we can simply plug in, and it's y equals to mx plus b. So m is 1, so it's just x, plus the b was 4. Okay, so maybe I'll write it over here. B equals 4. So that's important to keep in mind. Okay, so m was 1 and b was 4. Alright, going to the next one. And here's one more. There's actually many examples, as you can see in the notes, with slope equals 0, undefined slope. Make sure you review those, vertical and horizontal lines. But here is an interesting one. What if we have a line that's perpendicular to another line, y equals 2x minus 3, and it contains this point? Well, typically this is a two-step problem. Notice here we kind of got a little bit lucky because this is already solved for y. If it's not, you may want to do that first, which we showed in a couple of examples. So let's see. First we find the slope. Y equals, I specifically wrote it out again, y equals 2x minus 3. The slope is just the coefficient of x, which is 2. Again, remember, sometimes we need to solve for y, so make sure you do that first if you do. And I typically write it as m1 because this is not always the slope we need. Only if the lines are parallel, then it's the slope that we need. But in our case, the lines are perpendicular, so remember it's opposite sign, which becomes negative, and it's a reciprocal of 2, which is 1/2. So the slope that we need of our line is negative 1/2. Then we simply plug in y minus the y of the point. If you recall, it's negative 2 equals to negative 1/2 times x minus 1. So again, a little bit of a fraction work. I think I simplified it a little bit, and let's take a look what we get. Y plus 2 is equal to negative 1 half x. Again, we multiply negative 1 half by negative 1, we get positive 1 half. Again, we want to subtract 2, so I work it out on the side. Same idea, we get 1 half minus 4 over 2, which gives us negative 3 halves. And so the answer is y equals negative 1 half x minus 3 over 2. And that's it.